Hi there! Today we're going to be talking about an introduction to trigonometry using SOHCAHTOA. Now, trig is a big field of study with applications in a lot of different places, but we're going to keep it simple for now. See, at its core, trigonometry is about quantifying the relationship between angles in a right triangle and the side lengths of that right triangle. We accomplish this with SOHCAHTOA by comparing the ratios of the side lengths with respect to a particular angle in the triangle. Now, usually when we pick an angle, we represent it with that little symbol right there that looks like the circle with the swirly in it. That's called theta. Theta is a Greek letter that mathematicians usually use to represent angles. Now, once you either fix or find your theta, you have to qualify your sides like we do in the triangle diagram here. The opposite side is the side that the angle of theta opens up to. It's the side that doesn't actually touch theta. The adjacent side is the side of the triangle that is part of the angle of theta. Sometimes we like to think of this as the side that touches theta. And finally, the hypotenuse is the tried and true hypotenuse that we know from our Pythagorean theorem and other right triangle studies. That's the side of a right triangle that opens up opposite to the right angle. Or you can think of it as the longest side. That's usually the best way. And with that, we have everything we need to study SOHCAHTOA. So let's get to it. SOHCAHTOA is a mnemonic device that we use to remember the side ratios that we need to find the sine, cosine, and tangent of an angle. Now, what's sine, cosine, and tangent? Well, that's kind of the whole point of SOHCAHTOA, isn't it? Let's take a closer look. You'll notice here the three different colors for SOHCAHTOA to emphasize the fact that it's actually three statements. So, ka, and toa. The blue statement goes with sine. Sine is opposite over hypotenuse. Red goes with cosine, which is adjacent over hypotenuse. And purple goes with tangent, which is opposite over adjacent. So the gist is, if you're trying to find the sine, cosine, or tangent of an angle in a triangle, then the first thing you need to do is figure out what the opposite side is with respect to the angle, what the adjacent side is with respect to the angle, and then what the hypotenuse is, which is the longest side regardless. And finally, you're just going to set up the fraction from SOHCAHTOA. So if you're looking for sine, you're going to take the opposite side length and put it in a fraction over the length of the hypotenuse. Now keep in mind, a lot of times these fractions will be able to be simplified, and that's always a good idea to do, but depending on the situation, you may not have to. We're not really going to run into that here, though. So without further ado, let's go ahead and take a look at some example problems. In this problem, we're given a triangle with side lengths 3, 4, and 5, and we're asked to find the sine, cosine, and tangent of theta. First, we need to identify where theta is in the triangle, and clearly it's the top angle here. This gives us an opposite side of 4, an adjacent side of 3, and a hypotenuse of 5, which is the longest side or the one opposite the 90-degree angle. Now, if you're a little bit confused about why 4 is the opposite side in this case, I might suggest you think about it like this. If you drew a line from theta to the opposite side, that line would have to go through the middle of the triangle. Another way to think of it is that the opposite side is the one that's farthest away from theta. Now, I don't want to spend any more time on this, but if you keep getting these problems wrong because you're doing things backwards, it's probably because you're mixing up opposite and adjacent. But I digress. Let's actually get down to the problem. Now, according to the SO in SOHCAHTOA, sine is opposite over hypotenuse. So sine of theta is the length of the opposite side, 4, over our hypotenuse of 5. Very easy right there. Cosine, if we think of ka, tells us that we want adjacent over hypotenuse. And in this case, that's going to be 3 over, the hypotenuse isn't going to change, it's still 5. And then tangent, toa, tells us we want opposite over adjacent. So that's just 4 over 3. And that's it. Don't mix it up, folks. It is super duper easy. Okay, so moving on here, our next triangle has side lengths of 5, 12, and 13, and we want sine, cosine, and tangent of theta. Theta, of course, is here, and we're going to use that to identify our opposite side, which is 5, our adjacent side, which is 12, and our hypotenuse, which is 13. And with this information and our knowledge of SOHCAHTOA, we could solve this problem super fast. Sine, aka SO, needs the opposite and the hypotenuse. That's 5 over 13. Moving on, we have cosine, which is ca, which is adjacent over hypotenuse. That's 12 over 13. And then finally, we have tangent toa, which is opposite over adjacent, or 5 over 12. And that's all she wrote, folks. If you're trying to find the sine, cosine, or tangent of an angle in a right triangle, then first figure out what angle you're dealing with, use it to identify what your opposite, adjacent, and hypotenuse sides are, and then use the appropriate fraction from SOHCAHTOA. Hopefully that helps. I think it's pretty easy. Good luck. See you next time.